All right, let's kick this into high gear. I have 350 product records, but I want a lot more than that to really test out RethinkDB. So in our data directory, I have a number of documents here that I've used as real-world examples. I have Stripe checkouts. I have commerce checkouts from my work at TechPub. And I'm trying to make this as real as I possibly can. I want to use this stuff with Faker, but I also want it to be based on real information. So here's a Stripe response that I got for a successful credit card checkout. And here's how I've changed the generator. I've taken checkout information as a template from TechPub's sales engine. I've also taken fulfillment stuff. And all the data, of course, has been anonymized, and there's no real data I'm taking. I'm using Faker to generate the fake stuff, but I am using the same document structure to keep this as real as I possibly can. I'm generating fake addresses in here, and I'm calculating the amounts as accurately as I possibly can. I'm doing my best, is what I'm trying to say, to make this as real world as I possibly can. What I'm trying to do is emulate a really successful business. So let's flip over to our generator. You can inspect this code on your own in the download if you like. And if I run the generator, we are going to generate 100,000 sales because I think our business has been really successful. Isn't that neat? So it's generating the sales. It's writing them to disk. I'm not actually going to jam them into the database. I want the import tool to handle this for me. So that is kind of thing number one. Let the importer do the heavy lifting. It has been written specifically so it can do it efficiently. If you try and do it yourself, let's just say I know this from experience, you're going to crash your system. Anyway, I'm outputting those documents. You can run the generator yourself too. Just output the documents, and then you can run the importer as I'm doing here. I want to see how well RethinkDB handles pulling in 100,000 records. So I'm pulling in the sales.json file from the drop directory. And there it is. It has created a sales table for me. And what we can do is we can actually sit here and watch the import go off. And you can see the graph moving as the writes start to happen. And we've pulled in about 7,000. There's 18,000. And it's kind of fun to watch this. But notice it doesn't go incredibly fast. Our writes are right around 11, 12, 1,300 documents per second. But this can be influenced by any number of factors. As you're going to hear me say later on, the write speed depends on the size of document, of course, any indexing that you have on the table, whether you're using durable or soft writes, if you get replies back, and so on. In our case, we are using the importer, so that importer has kind of managed all that stuff for us. I believe it does 200 document batches, and that's why it goes so fast. Okay, skipping ahead a little bit, I'm not going to make you wait for the whole thing, but all in all, it took about 1.5 minutes, 94 seconds, to load 100,000 documents. It's not so bad. I don't have any indexing on this table. I'll do that in the next few clips. But if we want to count our records to be sure that we have all the data we expect, running a count, there it is, 100,000. Now, if you want to amp this up and go for 1 million or 2 million, go for it. It's up to you. You can take a look at the code and you can tweak it as you like. Okay, let's pull a document out and see what kind of information we have in here. This document represents a checkout. So this is actually a rather large document. And if you recall the big document approach, the process approach that I talked about in Thinking in Documents, then you'll recognize this. I've got a billing address, I've got a shipping address, I have all the items as part of the checkout itself. I have payment information. I have the processor response, and this is emulated coming from Stripe. And again, all this data is anonymized. There's no real information in here. Faker has created fake data for us. But this is a very real Stripe response format. I have referral information that I randomly dropped in there. I also have source and status as complete. I have some date information. So yeah, this is a big document. All right, let's do the next one. This is fulfillments. So when a user checks out, they create that checkout document, and then the system will create a fulfillment document. And this means stuff that our system, or maybe some administrative person somewhere, who knows, our warehouse, they have to fulfill that order. So since I have 100,000 sales, correspondingly, I have 100,000 fulfillments. But you'll notice this is going a lot faster. This is happening at about 2,000 to 2,300 writes per second. Well, that's because our fulfillment document, as you're about to see, is a lot smaller, so it writes a lot faster. In fact, it bears repeating that write speeds are influenced by so many factors. If I had thrown some secondary indexes on this table, it would be a lot slower. And correspondingly, if I had a bunch of shards and I had replications, it would be a whole lot slower. But anyway, the write went off pretty quickly. So let's take a look at one of our fulfillment documents, and I'll do the same thing that I did before. In here, we have a little bit less information, but we do have information about the destination of where the order of fulfillment is going to go, how many times it's been downloaded because we're doing digital items here, the email of the customer, we have an items list, but notice that the items list now is more about the download status or the fulfillment status of each item in that list. And we have notes. And in addition, I've dropped in notifications. This is the way I store data for orders. I want to make sure that whatever happens when fulfilling that order is tracked in a single document. This way, I can tell if emails were sent, perhaps some kind of messages back and forth, who knows, and any shipping information that goes along with it. Okay, there is our test data set. We are going to now ramp up our querying to work with something that's just a bit more real world.